Hello, thank you for joining our webinar today. We have our removable partial design expert, NCDT, Kris Schermerhorn. He'll be talking about Myerson's VisiClear flexible CAD partials. And without further ado, here's Kris Schermerhorn.
Hey guys, thanks for attending, taking time out of your busy day. Start out with a little bit about me. Grew up in the dental lab industry. My father started the lab before me and gave me a lot of insight into the dental industry. I work as much in the removable side as I do the fixed side. And it's been nice because the removable side is morphing a little bit into how we do the fixed side as far as digital is concerned. And so I'm going to try to pass some of that information on to you today. Worked with the development of a lot of these materials when it was an injectable material and still is an injectable material. And now we have it in puck form so we can mill it. And so it's a nice little transition. We'll share with you kind of both sides of things. I'm going to show you how you can mill it. And for people watching that aren't digital yet, I'll also show you how you can inject this material, because there's not all the time that you're able to digitally design cases for whatever reason. And it's nice to be able to fall back to being able to hand wax it and inject it in those instances. So the way the process is going to go, we're going to start out with kind of what the material is and why it's good stuff. Then we're going to transition into the digital design. I'm going to show you 3Shape. I'm also going to show you Exocad, just so you guys, anybody out there interested in how these different softwares work. They're very similar to each other. Most partial frame software is similar. There are little differences that are cool. Some have advantages one place where others have the advantage. So they're all really, really good. And so then we're going to transition into how you could make one by waxing and injecting, just to touch on that, just so everyone understands that. And then I'm going to go into repairing. One of the cool things about this material is you can repair it. You can add clasps, you can fix major connectors. It's as, if not more, repairable than a metal frame. So let's get started. So what we're here to talk about is the VisiClear material. The VisiClear material is a mostly clear plastic. The name has clear, and it is not optically crystal clear, and that's a good thing. Optically crystal clear materials in the mouth show shadows. When you're in a dark, shadowy environment, the clear literally absorbs that. Where a clasp rolls around a tooth and goes into an acrylic saddle, patients will look at it and say, look, there's this dark spot here. I take it out, try to clean it. There's nothing there. I put it back in. There's that dark spot. And what it is it's like a fiber optic fiber. It's allowing you to look all the way down inside that acrylic, and that's a tunnel. And what are tunnels? They're dark. And so with the VisiClear, it has a little haze to it, and that haze allows for, it kind of shuts down that transition of light. And actually, whatever it's sitting on, it absorbs. So if it's sitting on tooth structure, it'll absorb that and become that color. If it's sitting on tissue color, it'll absorb that and become that color. So it's actually a much better option. It's a little bit of a struggle when talking to a doctor. There's been a few materials that have come out for frames here recently that are optically crystal clear, and they have those issues. As well as, just keep in mind, anything optically crystal clear is going to be an amorphous, and amorphous plastics absorb moistures. And with moistures come stains, bacteria, and smells. And the last thing you want to absorb moisture is a clear material, because it'll show it. The VisiClear, we'll talk about that here in a sec, doesn't absorb any moisture, and therefore can only really stain on the surface if it's not taken care of. And if it does happen to stay on the surface, usually with a cleaner or repolishing, it comes up just like the day it was made. So, this is different than a lot of the clear materials you've seen, and better. So kind of talked about the amorphous. VisiClear is a crystalline thermoplastic, and that's why it can be flexible and be 100% dense all at the same time. Most things you think of that are 100% dense are brittle. The crystalline structure is what allows us to have that flexibility. Whenever you grind on it, whenever we injected most of this material, grinding on it was so much nicer than a lot of materials out there. That's why also it's able to be milled. And that's also why a lot of the nylon materials, like those other clear materials, very difficult to mill. You definitely have to have a wet mill, and even in that instance, spindle speeds are slower and things to deal with basically melting the material from the friction. This material, you don't have that, and actually grinds really, really nicely. Here's a couple of tests we did. Now, some of these paperwork tests that I'm showing, you're going to find that they, have Duraflex on them. And that's because Duraflex and VisiClear are the same thing, just the Duraflex has pink in it. All right, so anything you hear me reference as far as VisiClear is concerned or Duraflex, it's interchangeable. It's one and the same. And FYI, I'm not sure of the release date yet, but we will have Duraflex available in puck form as well, coming out probably not too awful far in the future. So when you see up here like the Duraflex partial, that's why kind of some of that's on there. But that aside, moisture absorption test, a leading clear based material, a nylon based material, over a 24-hour period took on 1.30% liquid, and was still going at that point. So after 24 hours, it was still going. The VisiClear or Duraflex took on 0.05%. That's as close to nothing as you can get. That was probably a slight, deviation in the surface or something. That's next to nothing. So that shows you the absorption of the liquid is next to nothing. Here's another test that was done. Again, these are a pink-based color, but that would, again, same thing as VisiClear. Duraflex and VisiClear are essentially the same thing. And so this was 50 days soaked in these different solutions that are very staining. This is the Duraflex. Of course, you can see no change between the different things that they were soaked in that would possibly stain it, because nothing can get inside. It can only sit on the surface. And if the surface is nice and shiny, nothing can attract. Down here is the flexible nylon-based material. And as you can see, the red wine made it just a little bit darker. The black coffee made it a little darker, and the black tea even darker yet. And so that shows you they take it on. And the staining is bad enough, but the absorption of bacterias that can get inside of this and then start to grow. You can soak it in different things, but you're really going to have to soak it a long time for that solution to get in to possibly kill those bacteria that are in there. So that's the more worrisome thing than the actual staining, is just the health of the patient with some of these materials. And so, that's just a nice little baseline of what this material is. It's kind of cool when we first developed the VisiClear to be able to be injected. We could figure we do clasps, maybe little unilaterals. It has a good bit of flexibility. But the cool thing about VisiClear and it being a crystalline plastic is, as you get a little thicker, that crystalline structure multiplies, kind of becomes a framework, and the material kind of gets a little stiffer, has a little less flex. And so where we might design a major connector on a Duraflex partial at 0.7 to a millimeter thick, we're going to design a major connector for a framework, because we want, most doctors are looking for a little bit more stability. That's why they're doing the framework. And what we do is we set it up so that we have about 1 millimeter to 1.2 millimeters thick. And that gives it just a little bit more thickness and a little bit more rigidity. Now, if you're looking for something way more flexible, you can affect that thickness. But generally, I found that at the 1 millimeter to 1.2 millimeters in the major connector is a really nice combination of stability and flexibility to have comfort. So here's our 3-shape. And so what I'm going to do is go through 3-shape, kind of show you how to design one of these and what the differences are. You're going to see similar things if any of you guys came on and saw my Zerlux Acetyl webinar. You're going to see similar design characteristics. When it comes to clasping and major connector design, there's slight differences, but generally very similar to that. And so with 3-shape, the way that they kind of characterize the undercut is yellow is kind of a mild undercut. Getting into the orange is a little bit more of an undercut, kind of a middle of the road amount of undercut. And then you get to your reds, where that's a pretty extreme undercut. The big thing to understand is is in this area. When you have a clasp and you're going to come around, where that clasp attaches to the major connector, you're looking at zero flexibility, and you're going to have acrylic on there. And having acrylic on there is going to keep that flask from moving for the most part at that point. And so we need to be at or above the height of contour in this area. All right, and then when we get to the middle, to the tip of the clasp, we can drop into just about the deepest undercut, even into some of the reds at the very tip. And so once your software shows you where the undercuts are, you can kind of position your framework so that you can, as far as the surveyor is concerned, you can position it so you can get undercuts where you want them to be. If you want less undercut in the anterior and more in the posterior. And then it's going to block that out. So it's going to take this area and it's going to add wax. So as you design your frame, stay above the height of contour in this area, then drop your clasp down in to gain your retention. Now, if you look at this case, it's a little light on undercut here, right? We're going to gain a little bit of retention, but it's a little light. Cool thing about these materials is if you do find that the retention possibly will be light, you can actually gain retention from the lingual. On a metal framework, the major connector has zero movement. And so you got to totally make it passive on the lingual. With these materials, they have flex and they can move into those lingual undercuts. And so you can come in and you can remove some of that block out to expose some undercut on the lingual, and then use that facial clasp as more of a reciprocation than a retentive option, and kind of let them work together. So when you're designing, especially on lowers or different cases, don't ignore that lingual undercut, that lingual retention that you could possibly use. All right, so here it is blocked out. All right, I've uncovered some wax. So with these softwares, they have a plus and minus. If you want to add a little wax, you hit the plus and you paint it on, essentially like you're waxing with an instrument. If you want to take some away, you hit the minus and you can remove some. You can also affect the translucency of the wax. There's a little dial up in the corners and show it here, but you can kind of move it from plus to minus and have it way more opaque or less. So you can kind of see what you're dealing with as you take some away. But like I said, our clasp is going to come from this side and then around. And so we're going to have acrylic here eventually with denture teeth, and it's going to cease to be flexible. So we need to be above that undercut, that major undercut. And then we can drop down into, on the tip of that clasp, into that undercut. With 3Shape, the way software, the workflow goes is it has you mark your mesh first, and then it applies the mesh, and then you mark your major connector. Exocad's a little different. We'll kind of show that here in a little bit. Either way, it really it's neither here nor there as far as what I've found. When you mark your tissue stops, you'll just put little squares, click, 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 around, make a little square. With these materials, make them a little thicker, a little bit more robust than you would with metal. And actually, I say a little bit more. I mean, you probably want it to be at least twice the size. It's flexible material. There's two reasons we put tissue stops on a metal frame. And the two reasons are amplified with flexibles. One is during try-in, those saddle areas, you want to be stable. So the doctor doesn't push back there and think there's movement or flex and it's warping, it's not fitting right. With metal, it's going to be fairly stable anyways during the try-in because it's very rigid. With this material, it's going to be very flexible. So you definitely need a nice, robust tissue stop back there to keep things stable during that try-in. Secondly, and probably the most important reason, is you're going to be packing or injecting acrylic to these. Now, if you're pouring acrylic, it's not as big of a deal. But when you're packing or injecting, there's literally thousands of pounds of pressure to push that acrylic in there. And you can definitely smush down a frame or move it. And then that acrylic, is in a dough state. So that frame is going to stay pretty much where it's been placed at. And then you cure that acrylic. And because that meshwork was kind of warped a little bit, the major connector then may have a little bit of a warp to it. And you're just going to have a bad fit after you process that acrylic. So having those nice, robust tissue stops is important for your processing. You'll also notice these large holes, if you will, as far as the mesh is concerned. I like the nice, big, larger holes rather than a bunch of little meshworks. For one, it speeds up the milling process a little bit, not a crazy amount, but it'll speed it up a little bit because it has less intricacy to deal with. Two, it makes everything, the acrylic flow through much easier when you process and all that. So, with a flexible material, let that acrylic flow through there and get on that underside. And just makes for a little bit more of a robust meshwork. So we're going to have some parameters preset probably in the next month where you can download, and they'll be named either the Zerlux Acetal or the VisiClear, and it'll be specific blockouts, specific mesh design for those. So you can look for that coming. But for right now, the gap, the blockout that's going to be underneath the mesh, generally the default's at about 0.5 millimeter, and that default's set if you're doing a metal frame. With ours, we want to make that blockout more. We want to have more space on the underside of that mesh, and so I like to take it up to about 0.8 to 0.9 blockout. That way we have more acrylic. Again, the more acrylic, the more gap we have under there, we're also going to have more of a butt joint. And we have acrylic, which is a rigid material, combining with a semi-flexible material. We don't want separation at that butt joint where staining can happen, anything like that. And so having a more robust butt joint, more materials kind of joining there, it's going to be rigid and solid and have less likelihood of any movement or separation and having any stain in that area. So the meshwork itself is going to be about 0.8 as well. So the thickness of the material on the mesh is going to be a little heavier than what it would normally set you up with metal. And the gap or the spacing underneath will be more. Once you mark your major connector, so with the major connector and software for 3Shape, it kind of has you mark two different spaces. You'll mark your major connector, and then you'll come around to kind of the necks of the teeth, and you'll mark that, and you'll go along and you'll go to the necks of these teeth. And then secondarily, have you mark the top half down to that lower half. And the reason it does that is it'll put texture, and whatever texture you choose, on just the material from that secondary marking down. And then from the second marking that you do on the linguals of the teeth, it'll make it nice and smooth and shiny. Well, we don't have to worry about that because we want acetal, the whole thing, to have no texture. The reason we put texture in metal is mostly just to break up the reflection of light. We don't want a mirror in there that's gleaming back at people when you yawn. Well, with the acetal, you don't have that, or with the VisiClear as well, you don't have that. It's a nice, material blends in, you hardly even tell it's in there. So we want it smooth because that'll be smooth to the tongue, less stains being able to attach themselves to the texture. And so all you have to do is just mark everything and then skip that secondary marking. The thickness of your major connector, the parameters that you see here, I've found work really good. I like the major connector to be 1 to 1.2 millimeters thick, and setting your wax thickness is kind of like your blockout, if you will. It kind of blocks out any intricacy, it kind of makes that surface smooth. Combined with the structure thickness of 0.8, actually, that you add those two together, you come up with 0.90. But I found that this actually winds up being more in that 1 to 1.2 range when you actually get it out and measure it. So kind of setting up your parameters here at these thicknesses works out really, really good. So once you've marked your major connector, you've marked your mesh, you have to do your clasps. And so these three pictures that I have here kind of take you through a couple different things. So we're probably going to have a clasp design when we send out our parameter download. But really, truly with 3Shape, one cool thing they have is you can go to any one of these dots that you've created in the designing, positioning of your clasp, and you can hit your control or function. And you hit your control, you roll your dice, roll your mouse, and it will widen and shrink your clasp. If you hit your function key, you'll fatten going out, and it'll actually tell you the measurements as you do it. Literally, it'll roll along. And so really it takes 2 seconds to kind of make the clasp the dimensions you want. And so what you see here is kind of just choosing a generic clasp in the 3Shape, the options that they have already. And over here, I went and put, this is going to be more like what I would want for a Zerlux acetal type clasp, right? So the Zerlux acetal clasp, that material has a little bit more stiffness to it, so you can be a little bit more traditionally designed over here. Then we jump to our VisiClear clasp. So the reason I wanted to show this is you kind of have your traditional metal clasp. We jump over here, acetal is going to be bigger, especially in the base area. And anyone who's used to now working with the Zerlux acetal, the difference between that and the VisiClear is kind of what you see here, where we need broadness. So this material has a little bit more flex to it. And in order to have proper retention and really aesthetics, I'd like the clasp to be much wider and flatter to the tooth. That's gonna make it more aesthetic because the light can pass through much easier because it's thinner. Also, food won't get caught on it because it's gonna be flat to the tooth, as easy. It won't rub the cheek, like a big old fat clasp would. And also in this area here, we're gonna be setting a denture tooth. And in setting that denture tooth, we want that to be nice and flat so that we can abut that denture tooth pretty darn close to that adjacent tooth. And so that's kind of why we're gonna be at about 4.5 millimeters in this area, kind of slowly tapering down to more of a pinpoint type clasp on the tip. On a premolar anterior, you might be 3.5 to 4 millimeters tapering down, whereas the Zerlux acetal, you are going to be more like 3 to 3.5. And then, also keep in mind when this material comes out of the mill, very nice to work with a handpiece and adjusting it. Grinds beautifully. And so, don't be, when you're first starting to design these, don't be afraid to make things just a little bit heavier on your clasps, and then just kind of dial it in and fine tune it, and then go ahead and measure them. Use your waxing calipers and measure what you end up with, so that, because you can make them just a little fatter and a little bit less broad. If you have a doctor, it's like, hey, I don't want these touching in the tissue at all. Then you can adjust. It's kind of one of the cool things about this material. Make them a little bit fatter, and you can make them a little less broad. And that way you can, and there's not a right way or a wrong way with either one of those designs necessarily. It is nice that it wouldn't touch the tissue, but it may be just a little fatter and just a little bit more of something on the tooth when they smile. So that's really something that can be kind of up to your own philosophy but like I said, make everything a little bit heavier and then kind of contour and shape until you dial it in, and then digitally you'll be able to have them come right out of the mill, snip them out, clean them up, polish them, and they're ready to go for a frame try-in. Finish line. So this is kind of our default for a metal frame. Again, I want that finish line to be just a little heavier. I want it to be a little bit more robust. It's again, hard acrylic. Acrylics do not chemically bond with this material, right? The material's great because it doesn't stain, doesn't absorb moisture. Well, that's also a little bit of a drawback when it comes to adding acrylic to it or anything. Now, acrylics don't bond to metal either, all right? So, it's similar thing. Just the metal is rigid and the acrylic's rigid, and so when they come together, they really don't move. With this material, you can have some slight movement, so having a little more a little bit heavier butt joint is going to allow for more thickness of materials there, and it keeps that area solid and rigid and keeps any kind of staining down to a minimum. And so here's our finished frame. I will say kind of my experience between 3Shape and Exocad, that 3Shape, whenever you kind of say, okay, here I'm done, it seems to be more done. When you kind of click your finals on your Exocad, there's a lot of smoothing and melding, your finish line into your major connector and kind of making a smooth transition. There's a little bit more of that compared to 3Shape, but both seem to, there's a reason why they're the two big big guys in our industry. Both of them seem to work really, really nicely. All right, so jumping from the 3Shape over to Exocad. I just wanted to make sure that everyone had a good view of how to create these clasps with both different softwares, because I'm sure we have some people out there that have the Exocad as well. And so one of the differences here, Exocad's kind of demonstration of the undercut is a little different, where the 3Shape was kind of going from a yellow to a red, transitioning through. Exocad goes from blue to kind of a green to yellow, orange to red, kind of this more gradual demonstration of the undercut. And so again, we want to stay above the undercut in this area because we're going to have, acrylic in this area. And then we can go down into a nice deep undercut at the tip, middle to the tip of the clasp. And so a little different here. Exocad has you mark your mesh. You can see my tissue stop there, nice and substantial. And your major connector kind of overlapping, has you do it all in one fell swoop. If you do have a rest, the VisiClear can have a rest, but as you can see in this picture, it needs to be a substantial rest. It needs to be deep and it needs to be wide. The material has flex to it, and in order, again, as we build up a little thickness, we get more crystalline structure, which makes everything a little bit more rigid. And with the rest, that's the idea. We want it to be more tooth-borne. And so if a doctor says, hey, I really want a tooth-borne, you got to explain to them, I'd like to see, 1.5 to 2 millimeters deep and as wide as you can kind of go, encompassing that area. And that's tough. Sometimes you just can't. And again, I'm not here to say that a VisiClear frame or a Zerlux acetal frame is it's the solution for every possible situation. It's not. But the cool thing is you could add clasps, clear clasp to a metal frame. And if the doctor truly wanted a tooth-borne partial and couldn't afford to put some substantial rests on there, you can make a metal frame and process your clear clasps to it using the Hotshot gun or something like that. Or you could process the whole saddle in Duraflex as well as the clasps. There's just so many options to make, for every situation with a lot of these materials. So you mark your major connector, your rest. You can mark your rest secondarily or kind of wax it in with some of the tools that Exocad has. I like, my major connector is going to be at about 1 millimeter thick. And so I'll kind of let that fill in, and then I'll just add a little bit to it with my waxing tool. And so with our mesh, same thing as with 3Shape, nice big holes, not a bunch of little diamond shapes or holes. We're going to have our mesh relief, about 8.5, like I said, 8 to 9 is where you want that to be at as far as the mesh itself, the thickness of the actual mesh when it's done. And then your relief wax, you want it to be about 8 to 9 as well. That's the block out on the underside of that mesh. Down here we have, we're going to choose smooth for our major connector. That's where you would choose whatever texture. We don't want any texture. You can see it's going to pick up a lot of the rugae and stuff being exactly thicker than what it's laying on, which is kind of cool. And then our major connector thickness, the default with Exocad is about 7/10 for a metal frame. We want that to be, again, 1 to 1.2. The broader it is, the thinner we can go. All right, so I would say if you have something of this length here, you could probably be at 1. If you want a little bit more rigidity, you could take it up to 1.2. I would never get any thicker than 1.4 with this material for any reason. If you have, for some reason, a kind of skinnier or major connector, less wide, then you would want to go up to that 1.2 to 1.4 thickness just to get a little bit more material there. A lot of times on lowers, you'll have kind of a lingual bar. So right down in that vestibule on the lingual, you'll have that pretty thick. You could even be as much as 1.8 just in that area, just at that lower, because the tongue gives a lot of space in that area. And then when you go up to your apron, then you'll be down to like 1 millimeter thick. because there's usually less room there, and that works out pretty well. And so here's our finished case. Here's a little video just kind of showing you the different angles of it. And you can see that kind of broadness here so that we can set that tooth nice and close up to that adjacent tooth. One thing that I will like to show in this video, so this is just a video of a VisiClear being milled, is you can look here, it mills beautifully, never clogs up a burr, it mills just like butter. I think it mills a little bit nicer than even PMMA, but you'll see it's a little chunky. The chunks that it of material kind of brings off are a little bit bigger. And the only thing that I have found you gotta be careful of, so, and you'll see again in this video, but I want to talk it through before we I show you the video, but over here is where it docks my tools or my burrs from my machine, and it's a rubber grommet, and I've never had an issue. It gets really kind of built up with chunky stuff. I've never really had an issue with it positioning a burr wrong, jamming in any material, kind of blows and cleans that area off before it places, and it cleans it pretty good. Never had an issue. Where I have seen an issue is with some mills. They have a docking space that's just kind of a magnet. It sets the tool up in a little cradle, and it's a magnet. And the one machine I saw wasn't really exactly set up right. It was set up to central vac from the lab, which central vac isn't a positive vacuum, as you know, or if you've ever experienced, they have trap doors at each bench, and you can kind of shut it, and it just lets the vacuum go somewhere else because it serves multiple positions. Well, that's kind of what happens. I mean, a cabinet for milling is pretty much closed, and so if you shut that, you need a positive vacuum. You need a vacuum that draws through and really pulls the air, and they really didn't have that. Also, this mill had a deflector, kind of a thing that focused the suction into the area right by the burr and the thing it's milling, and they had taken that off to kind of have access. And so those things combined, when I saw this mill, or if you have a mill that's similar to that, is the chunks kind of got up in that little magnetic cradle, and went to go put the tool back, it just didn't sit in there quite right. When I went back to pick up that burr, that tool, it didn't pick it up right and caused some problems. So I don't think it would be a problem if they had the proper suction and all the pieces still attached to their mill. But that being said, I don't, my experience is what my experience is, and that's all it had. So be careful. Definitely, monitor. This is a VHF mill that I'm using here, and have had zero. I've been just so you know, the VisiClear has kind of recently come out, but I've been milling it for about 1.5 years now, and I have a pile of used pucks. I mean, it's not a little bit. I've probably ran through a good 60 or 70 cases through probably about 30 different pucks. And so, yeah, and I've had zero issues with that. So if you kind of watch, I'm going to go in here, and you can kind of see the chunks everywhere. Okay. And so just be careful with that. Don't know that you'll have a problem, but you just want to, be aware that it's a little bit more chunky. And I've dealt with a lot of labs also that have been milling it and have had zero issues. So that one place that I was actually physically at the lab, and like I said, I think it was just the combinations of the issues they had with the way their mill was set up that more caused the problem. And I wanted to show this. One thing you'll notice is it comes out once I have the machine swipe over and kind of blow off the dust or whatever you want to call it from milling. Once it loads it, I have a puck changer. Once it loads it back into the puck changer, it's fairly clean at that point. And I wanted to show you guys exactly how it kind of looks just kind of coming out. Also, if you'll notice in the video, this material is flexible. Now, if you look here, especially in the video, I have support pins going all along here because I knew that there could be an issue with this flexing and moving as it milled. And that's a problem. This is a flexible material when it gets a little thinner, and we don't want it to be too flexible. We don't want it to move away from the tool, the burr, and we don't want chatter on the burr and break your burr or anything like that. And so what I did is, as it started milling, I just used some ball clasps, and I just supported that little piece. The crazy glue doesn't stick that great to the material. It's pretty resistant, but it helps to just secure that. It'll snap right off because, again, the crazy glue doesn't really adhere to the VisiClear, but it adheres enough to support that little piece. So keep that in mind as you put support pins. Really remember that this is eventually going to be a nice little flexible piece of material, an appliance. But while it's milling, we want it to be rigid and solid. I try to save up 2 cases so I can, position them in the puck together so they kind of support each other, but I can't always do that. And matter of fact, in that instance there, I think that was the 3rd partial I had snuck into that puck. And that'll happen. Most of the time you'll get 2 out of it, but every once in a while, small partial, you'll be able to sneak a 3rd one in. And you can do little things. You can use popsicle sticks. You can use, like I said, these are little old ball clasps, whatever to, support things as it goes through that milling. And then once it comes out, it'll really be close to polished. The texture and the surface is really, really nice. But there is a polishing kit that's available. It's available through Myerson, because they have an injectable version of VisiClear, and those you really have to polish. They come out, when you're finishing, they come out pretty rough, and it does a great job. You'll literally spend 2 minutes to give this a little high shine because the surface is already so smooth. And again, you can see the haze, right? So it has that haze to it. Once it goes down on a model, it's a blue model, it basically turns blue. It really absorbs that color and becomes whatever it sits on. So there's a little bit of education that needs to happen with your accounts. There's a little bit of, you got to kind of say, look, going to give you this clear frame. It's not going to be optically crystal clear. And here's why being optically crystal clear isn't exactly an ideal situation and why this material would be better. And once you kind of put that little, that they get that first case and they understand, they aren't surprised by it, they love it. All right, so kind of that's our digital design. Real quickly, I'm going to go through it real quick. I just want to show you kind of what you would go through to actually process one by injecting it. And no matter what, system, most every machine out there will process the VisiClear and or Duraflex. But the one thing to keep in mind is not every machine is super accurate. So you want to kind of dial in temperatures a little bit. There's the Flex Press, which is a fully automatic machine. It heats the flask up to the proper temperature and the material, and it's a push the button. It's like a porcelain furnace. You push the button and let it go through the process. So first thing you want to do is block out, right? Using a sheet of base plate wax, which is about 1.5 millimeters, heating it up and kind of pushing it down on the model. Usually we'll get it to be at about that 8 to 9 tenths thick, like we have in our digital design, and then just have that wax that's sitting there for your block out. Nice big tissue stop. Add wax just so you have a divot here. You want to have just a little divot along this area, a nice little trench, and then you're going to apply wax over top. You can see that blue showing through, and that's nice because then we're going to have, see that wax through. We can redefine our external finish line by using that as a reference point, right? See that there. Now we redefine that. We add our rests and our clasps. And then load it into your, boil it out, vest it, sprue it, boil it out, load it in your machine and inject. And you'll have very similar results as you would milling. It's just milling's a little easier to teach someone and a little bit more consistent, to be very honest. And I've been injecting VisiClear since 2003. So many, many years I've been familiar with this material and absolutely love it. Here again, two different little major connector designs on a model. You can see how the material really blends in, whether it's sitting on tooth structure or tissue. All right, that was kind of a quick overview on Myerson's YouTube page. They have videos on all different types of stuff, including dealing with VisiClear as far as injecting it. So you can check out Myerson Dental's YouTube page if you want more information on kind of the injection side of this and other things as well. And so I want to talk about repairing. So all my pictures are pretty much of repairing Duraflex. You know, the cool thing about the VisiClear and doing it in a framework is you have acrylic saddle. So if there needs to be a reline, doctor could do a chair side. There's just acrylic there. It'll adhere right to it. If they need to add a tooth, they can usually attach to the existing acrylic that's nearby to add the tooth. The times that you're going to need to do a repair on VisiClear would be if for some reason, which I don't know that I've ever seen, a major connector breaks, or adding a clasp. So that'll be a big one, really, is adding a clasp onto an existing case. And that's very simple. You can add a clasp on, have it done in about half hour. So what I'm going to do now is I'm going to show you some examples of how to repair this material. All right, it's going to be with Duraflex, but that's just Duraflex and VisiClear are the same thing, because I found if I show you multiple examples of how to do different repairs, you will in your mind get an idea of how to do repair when it comes about, because honestly, repairs are never exactly the same. And so giving people a round overview of how to repair in different situations, they can then kind of use their own experience and mind to figure out how. So in this case, we're going to add a tooth to this Duraflex. This is going to be with the Hotshot gun. All right, this is a handheld injector, and it allows you to do these repairs just super fast, no investing, nothing. So we wax our tooth in place, do a putty matrix, tack the tooth down in there with a little dab of glue just to keep it from falling out. We then, create a little space. We want to have a little gap here so when we push this putty down into place, the material can ooze out. But we don't want it to ooze out too easily, because as it is squished out, it's also going to be squishing up into the diatorics of the teeth and those areas. This little torch here is really, really nice. It's made by Blazer. It's model number SI100, and it just blows hot air out the nozzle. There's no flame that comes out, runs off of butane. The flame is kind of down in the base, and just hot air comes out the nozzle. So for repairing, for even doing some polishing, the little hairs that develop in areas, whether it's Duraflex or VisiClear, you can kind of hit them and they just kind of melt away to nothing. So it's a really handy torch and very cost effective. Through Henry Schein, I think it's, don't quote me on this, but I think it's like 70 or 80 bucks. So it's not a super expensive piece of equipment. Again, don't quote me on that price. Check with your rep in your area. And so you'll have the Hotshot gun ready. So it's essentially loaded with the material and it's melted. You'll then take your torch and you'll hit that area, getting the nozzle of the torch as close as you can for about 2 seconds. Then you'll bring the gun over, inject a blob in that space, pick up your putty, smash it into place like you were doing acrylic repair at that point. Material will ooze out. A lot of times I'll take a piece of tin foil wrapped on my finger, wearing a pair of protective gloves, and I'll just kind of smush that blob back in. Every once in a while you'll get a bubble here if you don't do that. And sometimes it finishes off, and sometimes you have to kind of do a second little repair for that. So if you smush it, kind of just takes that possibility away. Here it is after. You're always going to have a little flash you're going to have to clean up, but it doesn't stick to the teeth, so it cleans up pretty easily. And there's our polished up, no line of demarcation, no real evidence that a repair was done. Here's a Zerlux acetal. All right, so the process is the same, and the gun also processes the acetal resin. So, and this is more of a framework. As you can see, it was a bad impression. Wound up probably being a pretty washed out impression in this area, so the frame really doesn't adapt. This is a metal frame, that's a total remake. In this case, it's not. what you're gonna do is fill that area in with wax and then do a putty matrix over that area, like you'll see here. All right, so that just encompasses that. Clean all the wax off, get it nice and clean. Again, you're gonna take the torch and you're gonna go along here, heating, following it with the gun, putting a bead of material along there. Then you pick up your putty matrix and smash it into place. Again, you want material to be oozing because that means it's pushing it into the finer details. Here it is with all your flash. There it is all trimmed up, perfectly adapted to the lingual of that case now. Ready for polishing and to go back. All right, so before and after. So that's what I was kind of saying. It's probably even a little bit more repairable than metal. Sometimes you'll get a little, so let's say your burr goes a little crazy and puts a notch into your frame, or you're finishing it, you're cutting it out and you accidentally whack into the frame and you put a dimple in it or scar it in some way. You can actually take a little sprue. The gun always has a little excess. As you go through that process, you can make little welding rods with it and actually just heat the area, heat the rod, just squish it in there, let it cool, snip it off and smooth it up. And so the Hotshot gun really is a nice piece of equipment to have in combination with this, because it allows you to, basically it saves hours and hours and hours of time because you don't have to start over again. A lot of times it can be an easy repair, and it's just as good as brand new, these repairs. It's not a weaker material. It's not something that's going to stain worse. It is just as good as brand new. All right, another adding the tooth. All right, this one, heat here, inject a blob. All right, so more than what you expect to need. Smush your putty into place. You're gonna have that blob of material come out the lingual. Use your aluminum foil, works just beautiful. Wrap it around your finger and just kind of smush that back in. It won't stick to the aluminum foil, so that's why we use it. And there's the lingual and ready for polishing, cleaning up and polishing. So that's everything. Hopefully that was a nice little introduction into the VisiClear. So if you guys want to type in any questions, I can answer those. If you look on, you'll have either the chat button or the question button, and you can type in any questions you might have for us. One thing I'll show while we're waiting to see if any questions come through is, this is always difficult because I move the opposite way on the camera, but here's a puck that's been milled. All right, nice little variety of things. So you have a night guard, a bite splint. The times where I would do a bite splint would be, whenever you would have, like a clincher, because it has give to it. It has, it's not going to be super wear resistant like the Zerlux acetal, but it will have a nice clinching. You have a framework there, and you have your unilateral. One thing I want to bring up, this puck, it's nice and full. My mill's pretty quick. My mill will mill this out in probably about 4 to 4.5 hours. Other mills that are out there don't have quite the spindle speed. This is going to be in the mill for 6 or 7 hours. And not all of us can afford that. A lot of us actually have, some, other crowns and stuff to do. And I actually rely on CMC to help out whenever I have milling that needs to be done, especially this time-consuming stuff. The cool thing is, if you're getting metal frames from China or something, you could be down to like 60 or 70 bucks for a frame. If you are doing, dealing with a lab that's in the United States, $100 or more could be what what it costs you to get a metal frame. CMC, you'll have to talk to them about exact pricing, but CMC will mill one of these from your design for about 70 bucks. The puck itself is, again, don't quote me on pricing, but I'll give you a general idea, is about 60 to 70 bucks. And so, your material costs combined with them not, you know, it not having to take up time in your mill is really a nice thing to have that option to have them mill these for you. And if you're insecure about designing one of these, they'll do a $20 design fee. So you're looking at about 90 bucks. And that's kind of nice. You know, I actually trained them, you know, myself. And so they know what they're doing with design. And so, you know, send some cases to them and see the design coming back, you know, see the thicknesses and kind of get an idea for that. And then maybe see if maybe you want to tackle them yourself. And then again, it's great whenever you have that option to be able to mill those for you whenever your mill just really gets too busy. And then for other people out there, you're like, hey, you know, I spent a lot of money on this mill and I want it to be working. Well, great, keep it in-house and do it yourself. So, you know, just a really, really nice partner to be able to have. I actually, they do a lot of my metal abutments because they offer a warranty and the doctors really love that as well. So look into them, they'll really help. So we have a couple questions that popped in. Yeah, so great question, Jeff. As far as the strategies are concerned, it's great because the same tools that you use for PMMA work just fine, as well as the milling strategies. So PMMA milling strategy will mill us fine. We are working on some very specific milling strategies and maybe speed up things a little bit, but for right now, you know, as far as your mill is concerned, it's PMMA is what's being loaded in there and it'll mill it out just fine. So someone has a question about a roll and mill. So the roll and mills don't have a super fast spindle, but they will mill it. I have a buddy of mine, Savannah, Georgia, that does a lot of the Zerlux acetyl and a lot of these materials. He does a lot of little unilaterals and stuff. And you know, it's going to be a longer milling time just because to make sure we save spindles and don't burn them up with those type mills. You know, to do a frame, you're probably going to be in there for, you know, 2.5, 3, maybe even 3.5 hours for a big one. Whereas with like my VHF mill, it has a little bit more, a little bit faster milling spindle speed. You're probably looking at about 1.5 to 2 hours. That being said, if you have the time, you know, the mill's not being used, why not let it make you money? Okay, wet mill. Yeah, so it mills perfectly fine dry, but you can play around with your milling strategies and speed things up with a wet mill. But that being said, you're still limited to the milling strategies and the spindle speeds, whether it's wet or not. And so if you have a, you know, big industrial mill and it's wet, yeah, you can zip through these in a half hour. But most of us in the labs don't, some of us do. But if it's wet, that doesn't necessarily mean that it's going to, you know, you're going to be able to zip through these much faster. It's more based on your mill itself. Yeah, so kind of talking about the CAM software, you know, that has a lot to do with kind of the ability to mill. You know, some CAM softwares don't even give you a choice of choosing what you might be milling. And it's just assuming kind of it's crown and bridge. Now that we're getting into removables, I see that changing. I think a lot of these companies are going to step up and come up with very specific milling strategies for dentures as well as partials. But right now, some people are stuck with that. And it is funny when you watch one of those mill out of partials, it'll kind of mill out a section at a time, you know, and it'll kind of go and it'll kind of sit there and mill zip, 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 and then it'll go on and mill zip, 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 zip. And it's almost like it's doing a full roundhouse bridge and it just slows it up. Whereas if you watch my mill, it'll kind of come around and just go, and it'll just follow that whole parameter. And it just kind of makes continuing closer swipes, and it's just much faster. My CAM software has the choice of framework on there, which is odd because I don't know what else you would mill except for some of these materials. And, you know, it's been around forever, that choice of being able to mill a framework. Maybe it was for milling kind of a pattern to then cast. But yeah, the milling strategy definitely have limit, you know, they can limit the speed of it. But I see a lot of that stuff changing, even with your existing materials and mills that you would have. I think things are going to get faster. Yeah, so someone asked about the axis. So, you know, 5 axis is of course ideal, but really with these frameworks, there's very few undercuts involved. Really what I found, even with my mill with 5-axis, if I have a lower and there's a little bit of an undercut in the lingual, it won't really define that internal finish line very nicely. I have to go in and manually do that. That'll only happen to me like once or twice just because of a very undercut lingual area. And so even with 5-axis, that can happen. But it was very easily kind of done by hand. I just went in there and redefined that finish line. So if you have a 3 or 4-axis mill, I'm sure you'll be fine in probably 90% of the cases. And the ones that you aren't, like let's say there's a good bit of undercut in interproximal or something, and you go to fit it and it's just a little off. It's nothing different than if you were to finish a case and there was something a little off, you go in there and adjust it a little bit and get it to drop down and spend 2 or 3 minutes to adjust it to get it to go in place. So, like I said, 5-axis is probably 99% trouble-free. 3 to 4-axis is probably 90 to 95% trouble-free. So you're still in pretty good shape. Can the material be 3D printed? No, not yet. There's a lot of companies out there kind of 3D printing some thermoplastics. The problem with thermoplastics are, they shrink. Everything that you heat up expands, and then as they cool, they shrink. And you have layer upon layer, and you just build up these stresses. And if things don't cool exactly right, you have problems. And that's what I think we're seeing with some of the people that have tried to come out with something like that. And you're pretty much only consistent with like a unilateral or something small, and not with a larger type partial. It'll come, just like with dentures. They're working on it, and I'm sure that there will be some possible ability to mill some of these things, but right now just not really a feasible option. And so they're asking kind of with the milling software. I use VHF, their milling CAM software. Most of them do fine. If your CAM software doesn't have the choice of framework, but it does have the choice of bite splint or maybe surgical stent, choose those as what you're milling. Something of the same size. That way it helps kind of get away from that Krenner bridge type of a milling strategy and more towards something that's bigger, something that covers more space. So I think, so someone's asking about Millbox software. I do not have experience with that, so I cannot comment directly on how that specific software does. All right, I think I'm just scrolling through, sorry. Yep, so I think that's all the questions. We're at about our time limit. So how long, someone asked how long the tools last, kind of indefinitely. The material is probably even kinder on the tools than PMMA is on it. I kind of set my tools to go for about 100 hours, and I'll quite often let them go a good 25 hours to even 50 hours over. And I just kind of change them because I feel like I should, because the PMMA tools are only 30, 40 bucks. So yeah, they seem to last a good, nice long time, really kind to those. So that's another thing, when you're deciding on whether to have like a milling center like CMC do it or do it yourself, a little bit less wear and tear than of course zirconia would be on a mill. So even though it's putting long hours in, it's pretty nice hours on the mill. Yep. All right, great. So keep in mind, guys, if you have any questions, get in contact with CMC, with your Shine Zahn representative, and they'll be able to get you in contact. A lot of times I'm more than happy to answer questions for anyone. So they can get you in contact, or if they can answer the question, that's great. Contact them on exact pricing, contact CMC on exact pricing, so that, I know I'm in the neighborhood of the prices I said, but it's definitely not a quote by any means. And, thanks a lot, and we'll see you. This is Kris Schermerhorn. We'll see you next time.